Greeting, Professor and everyone. Today I will discuss about the final project of the networking essential class. And here is my full network topology about the AUPP campus. And I just wanted to let you know that this is not a 100% as same as the real topology of the AUP campus because I just do it from scratch just by walking around the campus. So this is just to inform you that I don't know the exactly the network topology of the AUP campus because I don't have the network map and stuff like that. I just working with the real-time scenario, which I see it every day. The first floor we have IT support, receptionist, and faculty offices. The first floor have labs, library, and also um, the office. And for the server, I don't know how many servers in AUP campus use. I just imagine it. So let's get into the project. First of all, I drag down the 4 routers here, 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 and here, and connect each other with the crossover cables to guarantee the network redundancy of this network topology. And the next step, I drag down 5 switches here, 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 and here. Just to mention, this is the ground floor, which has IT support, receptionist, and faculty offices. And this is the first floor. On the left-hand side, here we have labs, here we have library, and here we have faculty offices. And the last one is the server. And then I connect one router to the ISP, which is the Internet Service Provider, which in the real time, our Internet Service Provider is Mekongnet. So for in this lab, I config using protocol like HTTP, FTP, DNS, DHCP, POP3, and SMTP, etc. And for the network topology, I divided into 3 VLANs, which is the ground floor here, VLAN 10, the library here, VLAN 12, and here lab here, VLAN 30. And the reason why I create these VLANs just because I want to ensure the performance of this network runs smoothly and to divide the broadcast domain. So first step, I started configure the router's IP, which we can see here. This is the subnet between this router connecting to this router using this subnet. This router connected to this router using this subnet, as well as these two using this subnet, and here to here using this subnet. So we can check the IP configuration by going to the CLI and type enable configuration terminal, and we just do show IP interface brief to look at the IP that we assign. We assign here G00 with the 192.168.1.3.1, and it's up G01 192.168.3.5, which is up G02 192.168.5.254. And I did this all in the 4 router, but in the different IP. Just we have to make sure that all router has different IP to ensure the connectivity in the network. Next step, I just drag down the PC which in this case, in our school in AUP we have two rooms for lab here, first room and second room, and each lab have plenty of computers. I don't know how many, I just drag down just for enough. I think lab has like 10 up to 10 computers. That's why I added here. And this VLAN, and this is library. Our library has like three computers for our students to study, one printer, and this is the ground floor. So the second step, I start to configure the DHCP because there are so many clients. We cannot use static IP. We have to let the router assign IP address to the client by using DHCP. First up, I configure VLAN 10, configure DHCP on this router so that this router can assign the IP address to this VLAN. And the command line for this, I use here, I use IP DHCP pool VLAN 1, and then we allow the network in the subnet, which is 192.168.10.0/24. And then we specify the subnet. The default router is the default gateway and the DNS server. I do it the same to VLAN 20 and VLAN 30, which we can just change the subnet of the network and the default router, as we can see here. Next up, for the IP route protocol, I use the Dynamic Routing Protocol, OSPF, which stands for Open Shortest Path First. This is an easy protocol to config, so I decided to use the OSPF. And the command to config the OSPF, we just go to the CLI and we type the command router OSPF and router ID, which in this case I use 1. So first of all, we can assign the router ID, which in this case I assign, this is the router 1, so I assign the router ID to 1.1.1.1. The next step, we use the command network o.o.o.o 255.255.255.255. This is done. We do it the same on the other router as well. So when you've done this, you can check it by enter the command do show IP OSPF neighbor. Here, as we can see, this router is connected to the R3 and R4, which we can see here. The router ID 3.3.3 is for router 3, 4.4.4.4 is for the router 3. This is state it is operating in full, which is the SPF is working properly. When we already configure the OSPF dynamic routing protocol, we can test it by using the command do show IP route to ensure that the OSPF is in the routing table, which specified by O. O stands for OSPF here, as we can see. We can see O here, which is successfully. This indicates that we configured successfully and properly. So the next step, I configure the HTTP server. Here on this server, we go to the HTTP and I added the index.html to match the AUPP real website. We can test it by go to into one of these computer, and we can go to the first. We have to enable the DHCP here. Click on the DHCP, and it will request from the router, and the router will assign this IP to it, and we get to the web browser, and we enter the IP address of the server, and then we will see the website of the server, which is 192.168.5.2. We click enter, and here we can see the AUPP website. The second, I configure the FTP server so that all the client in this network topology can transfer file from each VLAN. This is the configuration. We can go to the service, FTP, and make sure we click the on, and then we can just add new or use the default one, which is the Cisco, and we can connect to it by going to one of these client desktop. Make sure that we have DHCP is enabled. Go to the command prompt and type the command FTP and the IP of the server, the final two, and they will ask for a username, which is Cisco, and password is Cisco. And here we in the FTP command prompt, which we can upload files, get file, something like that. One more thing is that I also config the ACL, which stands for Access Control List. I configure the ACL to block the FTP traffic from VLAN 30 to the server to ensure the network security, because in the lab we don't have to transfer any files. We just then the main purpose of the lab is just to complete the exam like that. We don't have to like transfer files from VLAN to VLAN. This is just to ensure the network security. And the command to configure this, I use the access control list extended as name extended. So we have to configure it close to the destination we want to block, which in this case I want to block VLAN 30, which is left from here to the server one. So I have to configure it on the router one in a G02 interface. And the command that I use to block the FTP traffic from this VLAN to the server is here. Here on the router one, first of all, we have to enter the command IP access list extended, and this is just the name. I identify the block FTP, and when we deny the TCP protocol, which is FTP, from here is the subnet of the VLAN 30, which is 192.168.30.0, and this is the wildcard mask. And then we specify the host that we want to block it from. I also disable here. Also, the FTP also use the port 20, so I just make sure that there's no FTP traffic from this VLAN, from the VLAN 30 to the server one. So I also deny the traffic from the subnet to this destination that its protocol port is equal to 20, and then we permit any IP address except 192.168.0.30.0, and then we go to that interface to adjust interface connected. Then we have to configure enter the command IP access group, and then the name of the access control list that we just create. And this out is to filter. It is here. We can see here the traffic will start from VLAN 30 from this and start here, and it will go out of the G02 interface. That's why we configure it out. Lastly, I also configure the email here, which is the protocol SMTP and POP3 to ensure that we can send email to each other in this network topology. So for the demonstration, I added the user 1 and user 2 just to demonstrate, and we can test it by go to any PC, go to the email, configure email, and we just enter the user name that we just configure on the server, which is here I use user 1. The domain is aupp.edu.k, which is our real domain here. We also specify the domain name. We use aupp.edu.k. Back to our demonstration. We have to enter our email. This is the IP of the server, and then our username and password. Click save. Then we can test it. Go to one more just to send email between each other. This is the user 2. The same, different is the username and password. Then we can test it by sending it to, I want to send it to user 1 at aupp.edu.ke, and the subject is just networking, and this is the message. Hey, check out my final project, and then we hit send. Then we can go back to this computer. Then we hit receive, and we will get the email from the user 2, which subject is networking, email, the send date, and the content, which is the hey, check my final project. And the final step is to test the connectivity between LAN in real time and in the simulation mode. First, I hop into one PC, make sure that the DHCP is enabled. Here, I use this PC, make sure the DHCP is enabled, and the IP is 192.168.20.7. We can test it by using the command ping 192.168.20.7. Let's see, does this client can reach the VLAN 20, the host in VLAN 20. Here we can see it reply from that PC, which means we can communicate with each other. Let's see it in the simulation mode. Click on the simulation mode. Same, hit the command ping, and then we just hit here the forward key. It will send it to the switch, and then to the router, and then the router send it to this router. This router send it to this router, and it will send it to the switch, and it will flood all the frame out of its interface to determine the address resolution for the call. And then before it does that, it will just forward it to the destination. Here, as we can see here, the message from this PC sent back to the this PC here. This PC here, out of here, let's switch to the router here to this router to this router to switch, and the switch will forward it to this laptop, to this computer, which means the configuration is successfully. So this is the end of my final project, and thank you for listening.